So hello everyone, my name is Hui. Today we will talk about the two-group discriminant analysis. So the main objective of the two-group discriminant analysis is find the best attribute set of a describe an object or the feature extraction and sample extraction to reduce the number of dimension representation of the model, and also find the best model to group the predictor variable. So to group discriminant analysis will consist of these steps. The first step is to formulate the problem. The second is estimate the discriminant function coefficient. The third step is to determine the significance of the discriminant function. The fourth step is to interpret the result, and the final step is to assess the validity of the discriminant analysis. So we go for the step one is formulate the problem. So the first step is to formulate the problem. We include these things that we need to do. To identify the objective and the criterion variable and the independent variable. So the criterion variable consists of two or more mutually exclusive or collective exhaustive category, and the independent variable should be selected based on the theoretical model of previous research, and the dependent variable, when they are interval or ratio scale, it must be converted into the category data. So the next step is to divide the sample into two parts. The first part is the estimation or analysis sample used for the estimation of the discriminant function. The second part is the holdout and or validation sample reserved for the validating the discriminant function. So when the sample is large enough, they will split the half. One half it means the estimation or analysis sample serve as the analysis sample, and the other half will serve as the validation, like the holdout sample. So the role of the half are then can be interchanged. The role and the analysis is repeated is called a double cross validation, and often the distribution of a number of the cases in the analysis and validation sample follow distribution in the total sample, and it has been suggested that the validation of the discriminant function should be conducted repeatedly. So in step 2, we will estimate the discriminant function coefficient. There are two main approaches are available to us now. The third approach is to the direct method. So the direct method involves estimating the discriminant function so that all the predictor will include in the simultaneously in the model. Like at the beginning, there are all the predictor variable in the model equation, and so when we use the direct method, is based on the previous research or a theoretical model, and the researcher wants to discrimination to be based on the predictor. So the other method is to use stepwise discriminant analysis. It's the same like the stepwise regression. It does the predictor variable are entered sequentially. So they enter sequentially based on the total variance can be explained by the predictor variable, and it can be used for select a subset of the predictor for inclusion in the discriminant function. So I will run to use the data in the SB. So as you can see, the book gives us the data. So to analyze the discriminant analysis, we will choose to choose the classify and discriminant. So I put a visit at the grouping variable and define a range that range from 1 to 2. I will put the income to age and the dependent independent variable and choose the enter dependent together method. In statistics, we will choose the mean univariate ANOVA and within group correlation. Click continue. In classify, we will choose the summarize table, leave 1L classification on group equal and within group. Click continue, and you can the result. So the result I will show us on the slide. So you can see that the household that visits a resort during the last 2 years are coded at 1 and those that did not are coded at 2. So in the table you can see that it appears that two groups are more widely separate in terms of income than other variable. Or the income in group 1 is about 60.5, but income of group 2 is just 41.9. It's the gap is about 20. And for the difference between the two groups in the age is more and the standard deviation of this variable is large, you can see that the ages of the two groups is the gap between is about 3 and the standard deviation is 8.77 and 8.27. So for the pool within group metric, we can still see that the correlation between these predictable variables are low, and there are, as we can conclude that there are no multicollinearity because it's about 0.19, 0.09, and there are not the high correlation between the predictor variable. So for the test of equality of the group mean, you can the significance of the univariate ratio show that only the income, the importance of the vacation and the household size had a statistically significant. That is significant is less than 0.05 or 5%. You can see that the income with the significance is about 0, the vacation is 0.2, and the house size is 0.001, and the travel and age has significant larger than 5%. We can conclude that in the individually the travel and age do not affect on the visit of the family. In the entry value, you can see that the entry value is 1.7, and then the canonical correlation is about 0.81001. So the canonical correlation we will square this correlation, we will get the R square is equal to 0.64, or you can say that 64% of the variance in the dependent variable visit is explained or accounted by this model. And the ancient value is also larger than 1, and it accounts for 100% of the explained variance has the significance. So we will move to the step 3. The step 3 is that determine the significance of the discriminant function. So it would not be meaningful to interpret the analysis if the discriminant function SMA will not have the statistically significant. So we can test by use the null hypothesis is that mean of all discriminant function is equal in all group, and the H0 is the alternative one is mean the vice versa, or you can say that the mean of all discriminant group is not equal or differently. So in the SBS, the test will be on the y lambda. So the y lambda is the product of the univariate lambda for each function, and the y lambda must have the p-value less than 5% to reject the null hypothesis and indicating they are the significant discrimination, and one can process to the step 4 and that interpret the result. At the table you can see that the y lambda is 0.359 and the chi-square is 226.1, give with the distribution of 5 give us the significance is about 0 will less than 5%. We can conclude that they are significant, have the statistically significant in the discrimination function, and we can go to the step 4, that is the interpret the result. So in the step 4 we will express the magnitude and the size of the coefficient. The relative importance of the variable can be explained by examining the absolute magnitude of the standardized discrimination function coefficient in the table, and the predictor will have large standard coefficient will have more important or more impact on the dependent variable, and the predictor with a smaller coefficient will show that it has less importance to the discriminant function or dependent variable. So we can see, you also can see the order or the rank of the magnitude of the predictor variable that affect on the dependent variable in the structure matrix table in SPSS. I will show you later, and there is also another way to identify the importance of the variable by using the canonical loading and discriminant loading. For the if the greater the magnitude of the structural correlation, they will be more important in the corresponding predictor. So you can see that the table of the standardized canonical discriminant function coefficient is that the income with 0.743, the vacation with 0.233, and the house size with 0.469. You can see that the magnitude of the standardized coefficient is suggest that the income is the most important predictor variable that affect on the visit or the dependent variable, and followed by the household size and the family vacation. In the structural matrix, we also see that the order of the correlation that affect on the dependent variable is that the income will have the largest, and followed by the household size and the vacation. So another way to see in the table is that to use the unstandardized discriminant function coefficient are also given to us. That's applied to the raw value of the variable in the whole set of the classification purpose. See as the group central table I will show you later, and the size of the coefficient will show the suggest that there are positive or negative relationship between the predictor variable and the dependent variable. So at the function group centroid table, you can see that in the group 1, they have a positive number is 1.2891, is the high, mean that there are the positive relationship between the predictor variable and the dependent variable. Is that the higher family income, larger household size, more important attached to the family vacation, more favorable attitude toward the travel, and the older head of the household are more likely result in the increasing in the visiting of the resort. And it also would be reasonable that to develop a profile of the group in the term of three main predictor important that we know before is that the income, the household size, and the importance of the vacation. To like when increase the three important predictor variable, we can increase the visit or increase the effect on the dependent variable. So the final step is that to assess the validity of the discriminant analysis. So we will know the new ratio is that the hit ratio. The hit ratio is the percentage of the case correctly classified then be determined by assuming the diagonal element and dividing by the total number of the case. So we will use the hit ratio is helpful to compare the percentage of the case correctly classified by discriminant analysis to the percentage that would be obtained by chance. So when the group are equal in the size, and the percentage of the trend classification will equal 1 divided by the number of the group, like such that there are two group equal in size, so the percentage of change is 1 divided by 2, mean that's 0.5. So how much improvement should be expected over change? So they are set that at least 25% greater than that obtained by chance to be accepted. So in the table of classification results, you can see that the hit ratio is uh, equal to 12 plus 15 and divide by to the total is that 30 is about 0.9 or 90%. And the leave out, you can see that 90% is stand for the 90% of the original group case correctly classified. For the leave out, one out cross validation correctly classified will equal to 11 plus 13 and divide by the 30. So we can have the 80% of the case. I can conclude that the 80% of the cross-validated group case correctly classified. So for the classification result in the whole L sample, you can see that you can the percentage of the group case correctly classified equal to 83.33% is equal to the 4 plus 6 and divide by the total is 12. So that given the two groups in the equal size, you can expect the hit ratio is equal to 1 divided by 2. We can get the 50%. So you can see that the 83.33% minus 50%, we can get a larger number than the 25%. You can set that the validity of the discriminant analysis is judged as satisfactory. So this is the end of my presentation. Thank you for listening.